All right. Yeah, I was hoping for people from testing to join because we have a few things on the agenda, but yeah, we'll see. We'll see if they show up later on. So this is Stateless Implementers call number 42, and I am copying the agenda right there in the chat. And yeah, I guess we can start with status updates. Does anybody want to start?
I can start. You hear me?
Yeah. Please go ahead.
Yes. Okay. So I published a Docker image with a binary tree in Bezu. So I did all of the modification normally for the next DevNet. So I shared this new Docker image to you, Guillaume, so we can try to start the new DevNet with this image as soon as we can. I was also still trying on the transition, so I had some issues, performance issues with my first implementation. So because I wanted to have a proof of concept with a quick implementation, the performance was really bad because I was using an RPC call for each pre-image during the transition, and it was too many RPC call. Even if I'm doing the generation of the data before the block, it was still too slow, and I had a lot of thread blocked, etc. So I decided to modify my implementation in order to have a first step before the transition. So downloading all of the pre-image and save all of this pre-image in the database. And when this pre-image downloading step is finished, starting the real transition. So today I'm testing this pre-image downloading step. I have a first implementation. It seems that it's worked, but I'm waiting for the end of the process to be completely sure. When I will be sure that this step is working correctly, I will start the transition thanks to this new pre-image in the database, and we will see. So yeah, still doing some tests. I think the main part of the code is here. It's not perfect, but yeah, I think we could have some good result with the last implementation I did. So I had to test, but I will be more confident with this implementation than the one I had before. So yeah, mainly working on that for the moment.
Okay. Thank you. I guess I'll go next. So, I mean, we've been working on bloatnet on state like analysis of the state. So, I mean, the concerned people will give more details about this. And there's also been some groundwork to get binary trees to work in Geth. Yeah, that's the general overview. I haven't touched 4762. There was a PR about updating 4762, which I got some feedback on, but not much. I will need to take some time to apply the feedback. But honestly, at this point, I think it's also a good idea to rethink 4762. So I need to have a conversation with the initial authors of 4762 and hopefully simplify this a lot. Yeah, that's pretty much it for me.
From my side, I've been working on bloatnet syncing, specifically trying to fix the issues with Ref, for which we added the required blocks flag, but still we have peering issues that we need to fix. As also, it seems that the PR for the multi-op code benchmarking is finally ready and accepted. So once we merge this one, like the rest of the PRs regarding bloatnet benchmark should be significantly easier to to bring to main. And finally, aside from this work, I've also rescued an old PR from Guillaume and Ignacio, in which basically I replaced the binary tree for the Verkle tree. Now my next step is to run the filling within East and produce all of the artifacts, and then run it against my branch itself. If that works, that should theoretically mean that we can already share these tests with Karim, and from there we can figure out what things work, what doesn't work, and we need to fix, and this kind of stuff. So yeah, I hope I have it this week. I mean, it depends on how many arrays I find, but ideally I should have it this week, and Karim, I will ping you once everything is done, so that we can start taking a look to the specific tests.
Any other updates? If not, we'll move on to the next step in the agenda, which is Hans' presentation about his article. So yeah, if you have the floor.
All right. Let me quickly share my screen. Right. So basically, what we have been working on for the past few weeks is we wanted to like learn more about the state access patterns on Ethereum. So Ethereum mainnet, to be more specific. So we did a bunch of analysis, and this is the first round of results that we get. And there were a few interesting findings that we get, but I think overall it's still like we're still scratching the surface, and there will still be more work to be done in the near future. So, but yeah, I'm just gonna give like an overview on the results that we get. I think for most of the client teams, maybe this wouldn't be like a huge thing for you guys, but there could be some things that you guys can utilize to perhaps like improve performance or do some caching on your site. So yeah, I think it's still good to know about all this data that we have. So all right, I'll just start right away. So the first thing that we wanted to know is that EOAs versus contracts, and which one actually lasts longer. So the main metric that we use is something called activity span, or you can think of it as lifespan, or it is basically defined as the block distance from the first to last access of a particular state, which is account or storage slot. So access here means on-chain read and on-chain writes, so as a store and as load for storage slot, or for the rest accounts that would be balance nonce, and code. Yeah. So one example is so if the activity span is 0, it means that a state, or let's say an account was first seen and last seen in the same block, right? So we actually see a lot of these accounts and storage slots in the next few slides. So looking at the first graph, we are looking at the accounts. So the first result that we get is, the conclusion is that EOAs definitely last longer than contracts. As you can see that actually 55% of the contracts operate for only a single block. So that's interesting. And if you look at the overall accounts, most accounts operate for only under a year. So about like 80%, and maybe like the rest of the 20%, they operate like more than 1 year, and with very little operate more than, for example, 5 years or even 6 years. I mean, if you look at like over 8 years, then that's like less than 1,000. But those are like really legacy accounts, and maybe some of like for example, accounts controlled by EF. So those are you see some of them here. And the next thing is the uniqueness of the contracts. So we wanted to analyze the bytecode and its relationship with all of the contracts that we have. So we basically categorize into two categories. One, what we call as template, which is basically bytecode deployed by more than one contract. And the second one is unique, which is basically bytecode deployed by exactly one contract. So majority of the bytecodes are unique. So that's the first thing. I think even in your clients, I'm not sure if you have something like a inspect DB tool. If you do like something in like DB inspect in Geth, then you will see this result as well. We have about like 1.6 million like unique code hashes in total, about that number. And if you do the categorization, then about 1.45 million is unique, like truly unique, and about 150K is like template, what we call as template bytecodes. So that's the first thing. And the second thing is that we have like most contracts are deployed using templates, right? So we have about 150K template bytecodes, but those template bytecodes are actually used repeatedly by about 48 million, or 48.7 million contracts, which is like 97% of the total contracts that we have. And in terms of the unique contracts, it's only like 2.9%. So that's a huge deal because it means that most contracts nowadays just basically just reuse as a single bytecode. And if you compare the activity span between these two categories, the unique contracts actually operate like 2 times. I mean, 2 times longer than the template contracts. So this basically suggests that perhaps most of the contracts that reuse bytecodes, perhaps they are spams, for example, like phishing tokens, right? So that could be one example. In regards to why is this the case, like we have to investigate more with the labels that we have in the future. So so that's that. And then when we look at the concentration and also the distribution, so on the left side, you have the cumulative distribution graph. So to simplify it, so 50% of the contracts, 50% of the bytecodes are only used by are only used by two contracts at most, and 99% are used by 728 contracts at most. Then you have 1% of the bytecodes are used by like millions or like basically more than this number. And we also wanted to know the concentration of the contract deployment, and the result that we get is basically here, like the top 100 bytecodes are used by 82% of the contracts. So yeah, this basically suggests that there is a few, like let's say for the first top 100, it's just getting reused again and again by different contracts. So again, what are those contracts? We don't know yet. So that's like further analysis. Then also quickly want to go through like who deploys the contracts. So we also wanted to know the concentration of the deployers. So I think we just focus on the right side graph here. So we do see like a huge concentration as expected. So basically we have a few guys, or actually if you look at the top 500, the top 500 deployers account for 57% of all contracts. So there are a few guys who are just deploying contracts over and over again. And for what reason, we also don't know yet. Yeah. And also quickly look at the factory distribution. Yes, I think we have a question.
Yeah, just regarding deployers, if the smart contract deploys, who would be counted there? The smart contract that deployed it, or the one that initiated the transaction, or?
Is the I think based on the data set that we have, is the EOA that initiated the transaction. Yeah.
Okay. Because I imagine that a lot of the duplicate contracts are like a DEX pool or something like that. That the because we observed a lot of the duplicate same bytecodes being deployed. And I assume it's just not actually being deployed directly by external accounts, but basically by other smart contracts just always deploying the same smart contract
Yeah.
because of the logic like DEXs or something like that.
Yeah, I think that would be something like the factory, like so basically smart contract. Like they execute the create or create to opcode. So so that could be one. But in regards to again, what are the contracts that are actually like deploying the same thing over and over again? We already get the labels, the label data set, and the next part is just to figure out like what are those categories of contracts that are just spamming, or I mean they might not be spamming, but like basically to understand what are they actually trying to do. Yeah. So we will know more once we do the analysis. Yeah. Okay. So just so to continue, we also wanted to look at the factory distribution and focusing on the concentration side. And we found out that again the concentration is also very skewed. Like the top 100 factories account for over 89% of all contracts, which basically supports the evidence that we have in the past in the few sites before, where like most contracts we use the same bytecode and so on and so forth. So yeah, and next thing is to look at storage slots. So we wanted to know the distribution of the storage slots by the activity span, and the first very important finding is that 63% of the slots only operate for a single block. So we have about 1.3 billion storage slots, and 837 million of them are I don't want to say useless, but we don't know how useful are they, because they were only read and written to in the single block, right? So yeah, why is that the case? We don't know. So we have to figure out. And similar to the accounts, most slots operate for also only under a year. So this is this aligns with the result of the accounts as well. So after getting those data, I think we have a few ideas that we wanted to share. They may or may not make sense, but it's just like a brainstorming thing that we wanted to share with the community and get some feedback, and whether we can turn them into EIPs or whether we can get more interesting ideas based on the data that we have. So the first idea is not really a new idea. It's basically what we have been like researching in the past, I guess, decade, which is state expiry. But I think one outcome that we can get out of this data for state expiry is to determine the period of expiry. So last time perhaps we were considering like 6 months or 1 year. So based on this data, it seems pretty clear that we should only keep like perhaps 1 year, and that's sufficient, at least based on the historical result. So in the past SIG calls, I also did like a simple benchmark on GEF, and we managed to show that we can save like more than 80% of the storage space in terms of the state size in GEF. So I assume that would be the same case for Besu and Nethermind, but I'm not sure about Ref and Aragon. Yeah. So the next idea that we had is something called like a temporary storage model, because this is inspired by the fact that most of the storage they only operate in like in a single block. So wanted to see if we can introduce a temporary storage where it's basically the same as the so-called permanent storage, but on the protocol level, we state that, okay, for example, after 6 months or after 1 year, all of the slots return to this temporary storage for all of the contracts. All of the contracts in the protocol, they are automatically cleared out. I mean, clear out as in logically clear out, but I would imagine the EL clients will run like a background process to clear out all of this data in the background. So yeah, so that's one idea that we have. The next idea is on improving the user experience. So when you deploy a contract, there's a bunch of calculation, and one of the calculation is the code deposit cost, which is 200 times the code size in bytes. So from the data, we know that most contracts we use the same byte codes, and byte codes are deduplicated in EL clients, meaning the EL clients do not store duplicate byte codes. So we were thinking that we can actually make like contract deployment cheaper by removing or reducing the code deposit cost, right? So there are two variants. I mean, there are three variants. The third variant is on libraries, but if you're interested, you can check out the original article. But the first variant is basically what we call a same block duplicate discount. So it's pretty straightforward. Like if a bytecode appears more than once in the same block, then the second and subsequent deployments get a discount. So the first immediate disadvantage that comes to mind immediately is unfair because it becomes like an ordering game where people will try their best not to become the first one to deploy the same bytecode, right? So there's this issue. And the second idea, which I'm more in favor of, is something called like a global code hash registry, where you have a system contract, you store all of the code hashes. So all the contract deployments first check if the code hash exists. If it exists, then maybe we can waive off the code deposit cost, or at least the cheaper one. And if it doesn't exist, then you have to pay the full one. So these are the two ideas. So I think one argument when it comes to making contract deployment cheaper is that we are incentivizing more spammy contracts, if that's really the case, because it's going to be cheaper to deploy the same, to deploy a contract with the same bytecode. So that's on the like a malicious party side. But on the good side, we can make a lot of things cheaper. Like if people are launching like proxy contracts, or perhaps, for example, like AA wallets or smart accounts. So those will most likely reuse the same bytecode. So maybe this might help with reducing the cost for those users. Right. So the next idea that we had is something called progressive per address storage pricing. I think the gist of it is that because so a contract can have unlimited number of slots, right? And all of the slots have the same price, have the same gas cost. So we wanted to see if we can make the cost of storing a new slot into the contracts based on the number of slots that the contract has. So for example, this is like a very simple formula. Don't read too much into it. It's like so for example, as a store could be repriced into 2,200 plus 10 times number of slots that the contracts have. So it's just like this 10 times num slots is just idea to show that, okay, we want to price it based on the number of slots. So the general idea is to tie the cost to the actual storage growth at an address. So it kind of like disincentivize people from spamming, like overly spamming too many storage slots. But at the same time, the disadvantage or something that is weird is that most of the successful contracts, they usually have a lot of users, and which means that they would naturally have a lot of storage slots. So we are kind of like punishing those successful contracts or successful applications to have too many slots, right? So this part doesn't really make sense, but again, it's just an idea to kick off some conversation. So yeah, I think overall, that's the gist of the data plus the ideas that we have. So in the next few weeks, what we're going to do is that we're going to analyze with more data sets that we have. So first thing is with the labels. Then we also want to find some short-term solutions that we can have. So for example, is there like a subset of accounts or storage slots that we can delete them and nobody would complain about them? Like we can for sure 100% guarantee that if you delete them, you'll be fine, right? So yeah, so more things that can be analyzed to understand the state patterns. So yeah, that's pretty much it for now. I think it's a bit of information overload, but yeah, I'll just stop here.
Thank you. Nice presentation. Is there any question for Han? Milos.
Yeah. One thing that would be interesting since you're doing more analysis, if you are accepting requests, it would be interesting to see in the first tier what would be a distribution. Like, are most of them use only one day versus one block, because one block is really short period of time, but like are majority of them actually used through entire year, or majority of them still fit in the category of maybe like 1 day or 1 week or 1 month or something like relatively very short term, and they're also forgotten afterwards? That would be one interesting. And also, if it's possible to know the ones that are considered one block, is that what is the distribution versus one block versus one transaction only? Because there is a temporary storage that already exists, the bytecode for temporary storage, and it's just a question of whether that's being utilized or not, if it's just used during one transaction or something like that. It would be interesting to know. But yeah, if you do like a more research, I think those will be interesting topics.
Yeah. I think that's a good idea. I think we also had a similar idea on like as part of our further analysis, which is basically to understand the intensity of the activity, because right now we are analyzing the activity span, which could be inaccurate in the sense that like we could have a contract that have a very short activity span, but during that short activity span, for example, like 1 month, it could have like a tons of activities. Whereas we could have a very long activity span, like those long time holders or whales or whatever. They don't really have a lot of activities. They just hold ETH, and perhaps they operate once in a while. Like perhaps throughout the 8 years, they only have like 5 transactions. So the activity is pretty, like in terms of intensity, it's very low. So I think it aligns with what you were saying just now. So that's definitely what we'll be looking at. Yeah.
Perfect. Thanks.
Any other question? If not, I do have one. And the question has to do with something I should have been asking a long time ago. But there was this article that was written by Gary when he discovered that Verkle, and I guess by extension binary trees, were planning to remove deletion of accounts, like account deletions and storage deletions, in the sense that if you write to 0, it's not the same thing as deleting a slot. It's not the same thing as deleting an account. Well, okay, so account deletion is already happening because of is already neutered because of 6780, but storage slot deletion is removed and replaced with a 0. Do you get a hunch? And once again, it's a bit of a. I'm not trying to trick you. I should have thought about this question some time ago and already asked it in the past. But do you get any hunch of if Gary is right to project that account like removing the ability to delete slots when you write a 0 to them is really going to blow up the state?
So I think like internally, Matan has this data on storage growth, and I mean we do see like I mean I didn't run the query yet, and I didn't see a result, but I did like run a small snippet of what he did, and we do see that there are actually a bunch of slots that are actually written 0. And so that's one thing. And then another thing is, if we do not delete them anymore, then that means we have to reprice it, right? So like that if we write it with 0, then it's no longer cheap. So
Right.
I'm not sure if this is going to be acceptable by the community. But I think there will be a significant impact. I think that's my hunch on the state bloat.
Right. Yeah, I mean, that's also what Gary said, but it would be interesting, and maybe that's you, maybe it's Matan. We should definitely check if 0 doesn't mean deletion anymore. we should try to see if we can confirm this, because then we would have two sources to say this is a bad idea, and that's going to impact the design of binary trees and vertical trees too. But that's not really an option anymore. So yeah, that would be interesting to have.
Oh, can you let us know why is that the case? I mean, why is it being considered for slots as well, or to remove deletions? Is it the same reason as accounts?
No, it's not the same reason as accounts. It's just that, okay, the reason is actually state expiry, if I understand correctly. I do not remember for sure, but my like, if memory serves, which it doesn't really at the moment, it was because we wanted to enable, like state expiry with several periods, using address space extension and everything. And the idea was that if you ensure that no account and no storage slot gets deleted, then you can prove that something was never deleted and resurrected. So you can't try to trick deleted. So that was my understanding of the reason for doing this. And Gary's argument was precisely, well, until we do have state expiry, this should not happen, because it's going to really blow up the state over time, and we do that for no good reason. There's another reason that I'm trying to remember, that might have had to do with the way vertical leaves were calculated, because if you delete, no, that's not going to work. So okay, I think that's the only reason I can think of. Maybe we should investigate that a bit deeper and see if anybody cares about this, and if no one cares anymore, well, then we can just say that's it. We're going to remove this from the spec and simplify our lives. Or, well, okay, it's not going to be simpler, because we're going to have to implement deletion inside vertical trees. Vertical trees or binary trees, which never occurred so far. But it's going to remove a lot of issues, at least in the Geth storage layer and the Geth database layer.
Okay.
Okay, so if there's no more question, let's move on to the next item in the agenda, which is the testnet relaunch. So Karim, you're more or less ready. And I think you and I were having a discussion, and it's rebounding on what you said earlier, that you have this new version for the shadow fork, where you download the pre-images. And you and I were discussing the possibility to, at least for the next testnet and the next shadow fork, to have a new format for key computation, where the key would actually be the Ketchak. It can be the Ketchak, can be the SHA-256, but of the Ketchak of the storage slot and the Ketchak of the address. And the reason for this is you don't need the pre-images if you're doing this, so it's a bit complicated, but it would be a nice first step for clients implementing shadow forks, that they don't have to worry about the pre-image distribution problem. And that's definitely not the final design, but we would like to potentially do this on the next testnet. So anyone having an opinion on this?
Just on the side, it will not simplify. I think it will be more complex.
Oh yeah?
Yeah, maybe you misunderstood, but as I said, I looked at the code, and for the moment, the current implementation of the binary tree structure is using a lot the pre-image. It's a refactor I did for Verkel, and if I want to go back to the hash, I think I will have to modify a lot of part of the code. But
Okay, so it's not a
It's
simplification.
possible, but it's more work. If it's not the final thing we want to have at the end, I think it will be more work for Bezo. If you want to go to this direction, having that at the end of the implementation, it makes more sense maybe to do some effort on Bezo side to implement it. But if it's just for some months or something like that, it will be more complex, I think.
Okay. Well then, yeah. Okay, if it's not helping you, then there's no point in doing this at all. I had another question for you in mind regarding. Oh yeah, you were asking earlier if it was going to be SHA-256 or Blake 3.
Yeah.
For me, personally, I would prefer SHA-256. The spec, I think, talks about Blake 3, but yeah, I think we should, if it's better for everybody, if it's simpler, we should do SHA-256. So unless someone opposes, we could agree on this.
And just one question, for the next DevNet, so do we want to just have binary tree or we want to have also the transition? Because for me, the next DevNet would be just a binary tree starting from zero or something like that. Or do we want to have a transition in the next DevNet?
No, I think no, we do want no transition, simply because if we want guests to join that testnet, that devnet this year, we will need to not have the transition. I think it's merging has been very slow, even slower than I anticipated. So guest is definitely not ready to do the transition at the moment. But joining the devnet that would have a vertical transition would sorry, I say vertical, but transition at Genesis would be the right way to okay, will be much simpler, and so it's realistic for us to have a two client devnet before the end of the year.
Yeah, because I also think for transition we need to define maybe a small specification, because for the moment I have a custom implementation calling another node thanks to RPC to generate the pre-image before the transition. But I think we need to have maybe the same way to work, like that we will be sure that this pre-image downloading step will take the same amount of time and will be ready at the same moment. So if we want for a future DevNet to have the transition, I think we'll have to work on this definition of how the pre-image would be downloaded, etc.
Mm-hmm. Yeah. Okay. Fair enough. Then, I mean, yeah, no rush in pushing a transition on the DevNet. You know, you're working on the shadow fork, which I think is the most valuable demonstration at this time. Yeah, as long as we have both, I think this is the best we can hope for realistically, and there's no reason to make things more complicated.
But if you think that removing pre-image will help to have maybe get sooner, I can try to take more look at the code to see if it will simplify the things or not in Bezo. For the moment, I don't think, but if it's a way to have maybe more client more easily, or I can try to take a look. But
so if I think the pre-image, no, it's not. It's really, that was really meant to help you.
Okay.
I have no, I have no problem, you know, generating those pre-images. We have had the code to do this for a long time. Yeah, it's not a problem for us.
So it will be interesting maybe to have a call later to see how you are doing that. Maybe I can try to have something similar. Just yeah.
I mean, yeah, we don't really need a call in the sense that I can just tell you right now. It's we're just having a node that is synced, that does a full sync from Genesis and records every pre-image ever used, ever seen. When we identify a block we want to do the transition at, we just stop the node and we go over the snapshots or the flat database. and we simply check the pre-image for everything, and we store it for everything that is needed, and we store it into a file, and then we put that file in another node, and that node does the transition. Yeah, that's a very painful, slow, manual process, but we know how to do it.
So you are reading the file every time to get the pre-image of the specific key, the key are in a specific order, so you are just reading the file in the right order, or?
Exactly.
Okay.
Because it's a frozen database, right? At the transition, so at the vertical fork, you start with an empty overlay tree, and you wait for some time before you start the iterator sweep of the database. So your reference file is always the same, and so you can generate it, and then you can even verify it by going over your own frozen MPT snapshot and verifying that the pre-image that you get, the next pre-image you get in the file corresponds to the next item in your flat database or your snapshot.
Okay.
And it takes about 1 hour these days to iterate the snapshot. So we're it's pretty fast.
Okay. Yeah.
Anything else you wanted to talk about on this item? Like the next item on the list was also the shadow fork. Maybe you want to give us an update on your status, but you kind of did already. So if there's nothing else to add, we can move on to the next item.
No, I think it's I already shared everything. Yeah, it's okay.
Okay. Great. So next item, unfortunately, we can't discuss it really because none of the people that would be able to contribute are here. But yeah, so it will be pushed to the next stateless implementers call. Simply just to give an explanation. We have, even before we do the test net, we have these execution spec tests that we've been running, and it was mostly at the end of last year, at least it was Ignacio writing a lot of tests to do this, and Guess would be filling those tests, and other clients, so in that case Besu and Nethermind, would be the ones consuming those tests and verifying that everybody agreed on the state, which is easier to debug than on a live devnet. So this is something we would like to do. We have hoped to do on before launching the devnet, but at this point, I think it's also valuable to launch a new binary devnet and still do that thing in the background. We have a branch that's called vertical/main. That is for Vertical that we need to adapt to binary trees. So Carlos was actually looking at preparing the guest PR to do this, and supposedly it should be agnostic. But the problem is that this branch is out of date. There's been a lot of changes in the execution spec tests. So we would like to modernize it and also bring it to after the latest fork, which is currently Prague and will be Osaka pretty soon. So yeah, ideally someone, both Ignacio and someone from testing would have been here so that we could discuss the feasibility of this. But today nobody's here, so I guess we just have to move on to the next item, which is also a pretty short item. We are planning to create a state analyzer panel, which might be on the Eastpendant Ops Lab website. And we were thinking doing some metrics, showing some things. So I have a document that is not really ready to publish at this time, but I can already kind of go over it. And my question would be, can you think of other things you would like to do? So let me look for the window, as I always do. Yes, here we go. So we have, yeah, I don't know if you guys can see my screen, but we have a state dashboard. So this document is going to be published this week. We still need some input from some people, but we would have a homepage saying this is, the state size by categories. So how much is the are the accounts, how much is the storage, etc., etc. This is the equivalent of a DB inspect in Geth if you do that today. We want to have a total state growth over time. Also rank the contracts. Try to like say this is the biggest contract, so SEN is the biggest contract. We also want to do something like what Paradigm did back in the day, but keep it up to date instead of just having a static rendering. Yeah, some suggestion that was given is to display the growth with respect to gas limits. So, when the gas limit goes to this level, how big is the state growth? Number, like, add some values like how much is represented by EOAs, how much is contract. So a lot of things that Han has exactly done for his state analysis article. Simply keep it up to date instead of just being something that gets published once and is forgotten. We also want to make a state expiry page. So yeah, roughly exactly what Han has done, but up to date, like kept up to date, so that we can see if there are changes in the pattern. There's an EIP I wanted to talk about, and then yeah, this is how we would collect the data. So it's not really interesting to talk about in this presentation. But yeah, so if someone has an idea of another metric they would like to see, we would like to hear this either right now, or we are going to try to publish this document this week. So if you have more information or more ideas as the week goes by, we would love to add it to this document. Yeah, that's pretty much it for that topic. If someone has questions, I'll be happy to take them. Yeah, otherwise we can end the call early.
If you can share the link.
Not yet. I will share it this week.
Yeah, because I wanted to share it to the team, like that they can propose maybe new metrics. Yeah.
Okay, so I'll tell you what. I will resolve a lot of the comments we have, and then I will share it. Yeah, I'll try to share it tomorrow.
Okay, thanks.
Yeah, so that's the end of the agenda. Is there anybody else who wants to bring some last-minute item? All right. Well then, thank you for attending this call, and we'll be catching up again in 2 weeks.
Cheers. Bye-bye.
Bye.